Welcome back to my channel. I am Roger. This is part 3 of my networking fundamentals course. In this video I'm going to be looking at network topology and types of LAN. Now guess what, I earlier in part 1 had mentioned that this would have been 3 parts, but when I went back to the drawing board I realized that the videos sometimes are a bit long, so in trying to keep them at a reasonable length, I decided to kind of separate some of the material. So it is actually going to be 4 parts. So this is part 3 of 4. All right. Again, if you haven't yet subscribed to my channel, I'm going to ask you to go ahead and to hit that subscription button, especially if you've been watching my videos and have been getting value from them. Please go ahead with that subscription button, and also like up the video then, please. All right, now let us jump right into the video. Let's begin by looking at what network topology is. Network topology refers to the physical and logical layout of the nodes on a network. And let me just break that down for you. So when we talk about nodes, we're talking about physical devices that exist on a network, and these may be things such as servers, routers, switches, printers. Alright, so any physical device that exists on a network would be referred to as a node. Now, these nodes can be arranged in different patterns, and it is the shape of the pattern which now defines the topology it is. And of course, this is all referring to a local area network. So this is essentially saying that on a local area network, you can actually have your nodes being arranged in a particular pattern, and that defines the topology. Next, let us look at the different types of topologies, and I'm going to be beginning by looking at the bus topology. The bus topology is perhaps the most common of all the topologies, and it is where you have a main cable referred to as the backbone, and so it runs along a particular path, and then you have the different computers now connected to that main cable, that backbone, via another cable. Hence it is referred to as a multi-point type connection, because there are, as I mentioned, that one main cable, and you have these different computers now connected to it at different points. The signals travel in one end to the other, and it broadcasts to all the computers that are connected on that main cable. This topology, the bus topology, is relatively cheap and easy to set up, and a significant thing about it is that there has to be terminators at the end of the cable, and that is to prevent data collision from taking place. Notice that the signal or the data was sent from this computer here, number 6, and it is sent along the bus until it identifies the particular computer that it is to go to, and once that has been accomplished, then the signal is terminated on the line. The terminators would be these things at the end here, the two ends, either ends. Now, in the other situation, now if there are no terminators, so notice that there are no terminators here at the either ends, then we're going to find is that the signals are going to bounce back on the line, and then you're going to have what is referred to as data collision. So the signals, the cable has to have those terminators. The other thing too, in terms of a limitation, if there's a break along or on at a particular section of the cable, what it will mean is that the data will not be able to be sent to computers to the other side of the break, as you're seeing here. Also, this topology, the bus topology, would normally use this T connector that you're looking at here, which is a BNC connector. That is how the cables will be connected to the back of each computer. Next, for our ring topology, the nodes are arranged in the shape of a ring. So the name of the topology essentially tells you, describes the shape of the topology. So the ring topology, the nodes are arranged in the form of a ring, so it is circular in shape, and each computer is connected to the other. What you find is that the packets go around the ring until the computer that it is to go to is identified. And a limitation here too is that if there's a break in the cable, then of course there is disruption in the communication process. Additionally, if one of the computers on the network is down, then that is also going to disrupt the communication process. So in essence, where communication is concerned, the data traveling on the network must pass through each of the devices on the network. And so you should be able to appreciate the fact that yes, if there is a break along the path, break on one of the cables, or if one of the computers or node is off, then that is going to disrupt the communication process. This type of topology is also a bit more expensive to set up than a bus topology. Next, we have the star topology, and the nodes here are arranged in the shape or form of a star, and communication takes place through the computers being connected to a central device. So this central device may be a switch or a hub. Now, a benefit, an advantage of this type of network, this type of topology over the previous two is that if one of the nodes is down, if one of the computers, for instance, on the network is down, then it does not disrupt the network, the communication process in terms of the data being able to get to other or another computer on the network, because there is a separate cable that hooks up each computer to that central device, whether it be a hub or a switch. So the switch or the hub is really that central, that nucleus of the network, that central point to which all of the devices are connected. And it is referred to as a single point of failure, which means that if that switch goes down, or if it is a hub, if it goes down, if it becomes defective, or is offline, then no communication can take place on the network. An advantage of this type of network is that the star is pretty much easy to facilitate scalability, so you can easily add a node to the network based on the arrangement here of the nodes. Next, for the mesh topology, I consider the mesh topology to be one of those topologies or a topology that is quite messy, because the reason for that is that when you look at this topology, you essentially have one cable for each of the computers on the network. So look at it this way: if you have three computers on the network, you would essentially have two cables running from each computer to the other two computers. Alright, so if you have three computers on the network, let me put it that way: three computers on the network, you'll be looking at about 6 cables there, because each computer is connected to each of the other computers on the network. So it is very expensive to set up because of that, the amount of cabling that will be required for this type of network. It also so it is expensive. The thing though is that it has a high level of redundancy, which means that the failing point or the possibility of failure is reduced because of the amount of cabling, which is and how the devices are interconnected. Now, the final network topology that I have here is the hybrid topology, and a hybrid topology is essentially a combination of the different topologies we'll have looked at. All right. So bear in mind too that within an organization, within an enterprise, you will not necessarily find, well, let me talk about necessarily, you will not find that the different departments would have necessarily the same type of topology. So they will utilize different types of topologies, based on their own particular need. And as a result of that, you would end up with a hybrid topology from the organization. So that concludes topology. Next, we're going to be looking at the types of LANs, that's local area network. There are different types of local area networks. The most common of them is the Ethernet type LAN, and there are different variations. So Ethernet, that's the most common, and there are different variations. So we have fast Ethernet, gigabit Ethernet, 10 gigabit Ethernet, for instance. What distinguishes each from the other is primarily, well, of course, enhancement in technology, which would boost the throughput, the bandwidth, and also as a result of that, that determining also the type of content that can be supported on the network. All right. So we see, for instance, with Ethernet being the base system here, it would have supported up to 10 megabits per second transmission speed, and then when fast Ethernet was introduced, that went up to 100 megabits per second. All right. Gigabit would have been 1 gigabit per second, that's 1,000 megabits per second, and then 10 gigabit would be 10 gigabits per second. All right. Now when we got to gigabit Ethernet, this now is where networks were able to support voice over IP. That is, where you would find, for instance, the technology being able to support telephone calls over the internet. All right. And also multimedia, streaming and so forth on the network. We also have ATM, which is asynchronous transfer mode. So this is also a type of local area network setup, and this primarily is facilitated through telecommunication networks. Of course, it supports voice, video, and data formats. Where this is concerned, we're looking at things like the sending of messages. So asynchronous means transfer or data communication in one direction. All right. So we're looking at, for instance, the sending of emails. You send also like a message, like a WhatsApp message, right? That would be a form of asynchronous transfer mode type communication. You also find ATM being used in VPN, virtual private networks, and essentially, an essential point to ATM is that there is point-to-point transmission, which means that the communication is from one point to another point. Next, we have PoE, which stands for Power over Ethernet. And where this is concerned, it is essentially the ability of a network device, typically a network switch, being able to power a network device remotely. Okay, so traditionally, when you look at network devices, look at something like a surveillance camera, those analog cameras. They required, based on the technology, they would have had to have two different cables going to them, running to each. So we'd have one which supplies electricity, and the other which it would be for data transmission, right? So that would transport the video signals. Now with PoE, we now have our current network cameras, which are digital, and they are powered differently. So what happens in here now is that the Ethernet cable that that same Ethernet cable that is connected to the surveillance camera, which transports the data, a couple of the copper cables on the Ethernet cable is used to supply current to the camera. Alright, and that current is supplied via the network switch. Alright, so in a nutshell, a PoE switch, the difference between a PoE switch and a regular switch is that the PoE switch is designed to be able to power a PoE network device from the ports. Okay. Token ring is another type of LAN, and let me just add that this type of network, this type of local area network is pretty much obsolete. In the token ring, the connectivity is in the form of a ring, but the essence of it is that transmission is in one direction. Alright, so it's one direction only, and of course the tokens enable the nodes to transmit data. Now finally, there are also local area networks that are designed using fiber. This is where we are now in terms of a wired transmission medium, and that is using fiber. Now fiber is a high-speed data transfer. Fiber optic cable is a high-speed transmission cable, and the transmission takes place through light transmission. So light is passed through, a light signal is sent along, is transmitted into the cable, and it reflects. So you have reflection, and that is how the communication process takes place. They're pretty fast. You're looking at speeds starting off at 1 gigabit per second. Okay, that's it. We've come to the end of the presentation looking at the types of network topologies and types of local area networks. Again, please remember to like, share, and to subscribe to my channel if you haven't yet done so. Hit the notification bell also, so that when I upload a new video, you'll be automatically notified. I'm Roger. See you again in the next video. Take care.